if I get statements like they don't scare me anymore. If they say without the use of a calculator, I know which is basically the person is polite. It's a polite way of saying to us, don't have an answer like this. If you get an answer like 0, something, it should scare you. We don't want to care. That's what they are saying. That's all it means. Okay, so we're supposed to evaluate the following trigonometric expression. How does this thing work then? We're given 310, we're given 210, we're given 330, we're given 225. What we're supposed to do here now is to introduce, let's start with what we already know. We already know that we have a cast diagram. And then we said on our diagram, we have 0 here. We have 90, we have 180, we have 270, and then we have 160. So that's what we already know for sure. And we said we can repeat the cycle like adding 90. So what we know is that these angles, they have the ability to reduce. They can make something bigger, they can make it small. You remember that? They can make something bigger and then they can make it to be what? To be small. Now I want to introduce new people here. These guys, they don't have the ability to reduce, but they are special. You get the difference again? These guys, they don't have the ability, they can't make things small, but they are what? They're special. They're special in a sense that we can get them using a diagram, but I'm going to short circuit it and then use the calculator to get them because we're using a Casio calculator. Now, if we have 30, we have 60, and then we also have 45. These guys here, they can reduce, and they are also acute angles. They are special. They can reduce, but they are special. So these guys are special. These guys here, this one vertical line, it's CR again. And then these guys here, it's R only. They can only reduce again. So we're adding new group of people, man, into the mix. We're adding people that they can reduce, but they are special. So what we're going to do here, Mashita, is to rewrite this thing here first. The first activity that we're going to have is to rewrite the following people such that we use the combination of this one and the people that can reduce. We have 210 again. We are going to rewrite 210 such that we use the combination of what we already know, which is the reducing again. Now, why the reducing? We need them to reduce certain things. This thing here is big. If it's 210 is big, we want to make it small. We want to make it smaller to what? We want to make it smaller to a special angle. We want to reduce it so that it becomes a special angle. How then do you do that? That's what Spanyon is asking. You're asking how then are we going to do that? We add or subtract it, which would depend. We'll see, like which we add or subtract. Let's come up with a way to say how are we going to know whether we add or subtract. Let's go and check 210, for example. Where would you find 210 if it's you? Think about it. You are going to find it somewhere here. So I will say, okay, this is 210. I will write 210 here. 210 again. Now, if I'm going from 108, let's say I'm coming from here. It's just like giving a person a direction here. If you are going from 108, you want to go to 210. What do you say to the person? Are you going to say to the person add or subtract? What do you say? You're going to say add. Now, then the question is then this. What should we add here such that we get this? What is the angle that we can add here such that it's going to give us 210? And then the angle that we are choosing for now, for today's lesson, the angle that we are going to choose, it needs to be part of the people here. It should be part of these people here. So what should we add here? 8. So we're going to say here, if we say, you see, it's not necessary to say I need to add or subtract. So I will say, instead of writing this thing here as 210, I will write it as sine. I'm going to write sine like this. So this is sine, open bracket. And then here, I am going to write this 210 in another way. So if I write 210 in another way, it's going to be 180 degrees plus 30. What have I done, you guys? I've changed to 210 and then I wrote it in a useful way. How is this useful? It's useful such that we have someone who can reduce we have someone who is special. Special angles are acute angles, they are small. Reducing angle, they have an ability to make something to be actually to be small. Now, is this the only way I could have written this thing? No, there's another way I could have written this thing. I could have said, okay, what if I'm starting from here? What if I'm starting from 207? If I'm starting from 207 and then I go back here, I want to get 210. What should I do? So I'm going backwards. Right? So it's either you're going forward or you're going to what? Backwards. Now, how do you know which one is forward, which one is backwards? Mathematically, we measure our angles anti-clockwise. We move this way. So if you go this way, you are going forward. If you go this way, you are going what? Backwards. We are subtracting. So another way this thing, another learner can say that I said, I could have written this thing this way. I could have written it as the sine of 270 degrees minus. What should I add here? I'm subtracting what so that I can get 210? 60 degrees. So we've written, and then you can see this. I'm writing 210 in another way. When I type these guys, this is going to give me 210. This here gives you 210. And here's a little bit. So mistake number one, guys, we didn't do this. Look at this. We didn't say it, we didn't say 180 degrees plus 210. We didn't do that because if you say 180 plus 210, it doesn't give you 210 anymore. Whatever I write inside the bracket, it should give me the whatever is at the original there. It should give me whatever is written here. You get what I'm saying? Yeah. Okay, let's try this one here. If you feel which you are getting it. We should just be careful if we use 270 and 90, we should be cautious of the fact that 270 and 90 they change and reduce again. So if I use 180 is fine, it only reduces. In fact, if it's 10, if you see 10, don't use 270 and 90 degrees because you don't know 10 changes to what. Again, we haven't done that. We did it in grade 10, we said it changes to cot, but in grade 11, we haven't done it. So stay away from 270 and 90. Yeah? 1 over cot, yeah. So we say here we have, we said this is going to be written as, we are adding 30 degrees there. Okay, fine. Let's try this one here. So how do you know how are you going to write this thing? You go on your cast diagram again. Stop it. Look at this. If you go on your cast diagram, where would you find 330? Ask yourself that question. Where would you find 330? You find it here? Yeah, you come here and say, okay, this is 330. You write 330 here. So you have 330 here. Yeah, I'm coming, guys. Still coming. 330. All right, good for us. So from here, we can either go this direction again, or we can go this direction again. So from 270, should I add or should I subtract? I should add. But I can't use 270. You see why? Why? Because of time. Yeah, I in essence, I could use it. I mean, I could use it, but you can't. I shouldn't say we, speak like a comrade. We. All right. So here, what are we going to have here? We're going to multiply this. Let's write our 10. We're going to write 10 as what? So we should write our 10 as what? It's 10. So what are we going to say? So we say we have 360 degrees minus 30 degrees. All over. We have 225 all squared. The squared shouldn't stay out again. The squared means which you are going to say, okay, we have the sine, open bracket, and then we put the square outside, close bracket. So we have 225. Where would we find 225? So is another column. We find it where? Here. On the 10th quadrant here. Okay, that's where we're going to find our 225. It should be the other again. Okay, so if we go in this direction, we're going to add again. And then if we go in this from 270, we're going to do what? To subtract. So let's take 270, since the sign again. We haven't used 270. So let's use it now. So we'll use 270, and then we're doing what? Subtract. Subtract what? 45. Okay. Now that we're here, then we're going to write this thing here exactly like what we're doing here. Remember? When we were here, we said something like this. Let's just remind each other. Here, we said this thing here is going to be written as a sine of an acute angle, whatever the acute angle is. So I was saying to you the other day, guys, the acute angle here shouldn't be a variable, it can be a numerical value. So we are going to write this thing as an acute angle because 540 has the ability to reduce. 90 has the ability to reduce. So we're going to repeat exactly that same process here. So we say we are here. Come and check 108. 108. Reduce or reduce and change. Let's go back to what we were doing before. It reduces on. So we are going to have this thing as the sine of 30 degrees. Why 30 degrees now? It's because we no longer have A, but what acute angle here is what is 8. So this thing here is going to be written as the sine of what? Of 8. Can we repeat what we just said? Guys, we're saying, remember, here's what we had. This is what we had yesterday. So what were we saying from here? We said 540 can reduce. Okay? Then the only thing that we have to ask ourselves is this question. 540, does it reduces and change or it reduces on? That's the question that we're asking. It reduces on. Okay? So if we have 540, in other words, like if we want to break, loosely speaking, this is what we're doing. We were cancelling this part here, but that's not what we're doing. We're removing this part here, and then our answer was meaning as what? As sine of A. So the reducing angles, they can disappear. And that's what we were doing before. Yes. So the reducing angles, we are removing them because they have the ability to make this thing to be small. We are going to do exactly the same thing here. Nothing has changed. Here we come and say, okay, when you should be gone. Who should be gone is the reducing angle on again. So if the reducing angle is gone, what is going to remain there is what? It's sine of 8. And then here, who should we remove here? Who are we going to remove? And then we don't take it with the negative sign. We took it, all of them, we took them as positive. Okay? So what are we going to have here? Multiplied by the 10 of 8. We put it inside the bracket. Yes, I'm listening. We'll come back to the, remember, Tina, how we're doing it, we are not doing it to say we put the sign first. First, we reduce it. Okay? Steps what we said, first we check, and then we reduce it. After reducing it, then we go step by step using our calculator to check whether it's positive or what, or negative. So guys, you see, like, I don't want to diverge from what I already told you. I want to stick to that. So the only difference is that now, instead of us starting here, we're not starting here. In this activity here, we were starting here, they already gave us the reducing angles. So here, they don't give us the reducing angles. So now we first start by giving them the reducing angles first. After giving them the reducing angles, that's when we start from there. Does it make sense, but? Yeah. So, but all the steps that we're using before, they are still there, except with now, we're adding new steps here to accommodate this new thing. On our cast diagram now, we are adding which way is 308, where is 220. Okay, let's move on from here then. This one here is going to be written as the one on the denominator. So the one on the denominator, we have 270. 270 reduces and change. Okay? So what are we supposed to have? We're going to have the cos of whatever angle is there. So the cos of 45 there. And then this here is also going to be all squared. Okay, now machine. Then we can go and talk about being positive or being what? Being negative. How did we do it, machine? Nothing has changed. We said we're going to use the +1 method. Shouldn't stay us. Instead of an acute angle, so now we don't put an acute angle, they will just put 1. So whatever they've put that, we're simply going to put 1. We're simply going to put 1. So we go and say, okay, again, nothing has changed. We have the sine of 180 degrees plus 1. We just want to check whether it's positive or negative. So it says, what are we going to have? A positive or negative? Negative. So we have a negative here. Okay, next. Next, what are we going to have? So it's 360 minus 1. Okay, we have the 10 of 360 minus 1. Actually, angle is 1 again. So what we have? Negative 10. So you see what we're talking about, machine. So it's negative. And then you have 270. What you get here? You can try that again. You don't type it with the square. You say, okay, you are going to have the sine of 270 minus 1. So why the minus 1, guys? When we check, we use +1 method. Always. When you check whether this thing is positive or negative, use the +1 method. Okay, now, before in our time, we had the following diagrams. And then from here, we'll come and use the diagrams. Our diagrams were like this. And then here you will have 30. And then here you'll have 60, 90 degrees. Yeah, we used to have these diagrams. And then when you're using those diagrams, then from there onwards, you'll come and say, what is sine of 30? And then they'll give you an answer which one is going to be the sine of 30. Now, since times are evolving, instead of using that diagram, I am going to use my guy here. And then I will say the sine of 30 degrees. The nicest thing about this is that it's also going to give you as in a fraction form. That's what we want. So it gives us in a fraction form. So this thing here, the sine of 30 is going to be given as open bracket minus 1 all over 2 multiplied by the 10 of 30 degrees. And then this gives us minus √3 all over 2, if I'm not mistaken. What did it say? All over 3. Close bracket. All over. And then you see when I type it in my calculator, I don't type it with a positive or negative, because I already know it's negative here. So after that, I'm going to have minus. And then you type 45, you say cos of 45 equals to, and then it says √2 all over 2. This should be all squared. And from here onwards, then Mashita, you can come and finalize your answer. You go to your Kesho calculator, you're going to type this thing exactly the way it is now. They want to see this, there's a mark for doing this, there's a mark for doing this, there's a mark for doing this. So you need to show them that. Basically, they are saying use that diagram, but I'm saying the Kesho calculators can give us the values that we're going to get on the diagram as a rational form. They even go further, Kesho calculator gave further to make it to be rational, because they don't leave our answer as a root with the denominator. Okay, now when you type this in your calculator, how are you going to type it? You're going to have open bracket. So you have open bracket minus √1 all over 2. Close bracket. Multiply this multiplication again. Multiplied by. Guys, it became quiet, man. Did you still follow what's happening? Yeah. Okay, so we have √3 all over 3. And then we close the bracket. And then we have √2 all over 2. Close bracket all squared. So don't forget the square again. And then now you say, Mr. Keshe, give us the answer. Mr. Keshe is going to give you √3 all over 2. I think we got what √3 all over 3. And then this is how we approach the question. Now, this is you. So we have our classwork. This is our classwork.